So, welcome to e-Pathshala. Now we are going to learn about geometric properties and tensile properties of the fabric. So, for the fabric, the geometric property means the surface properties like feel, structure, how it is going to be made. For example, the fabric is made up of plain weave, dyed one or checked one. It is irrespective of the fabric. We have to know what count it is made up of, how much ends per inch and pitch per inch is going to be. Next will be how much crimp it will have, how much GSM, grams per square meter will have. These are the properties we have to test, and also what is the drape of the fabric, what is the stiffness of the fabric, what is the behavior of the fabric during bending, what is the pilling resistance of the fabric. These are the surface properties which will yield the fabric properties to know the geometric level of the fabric. The one important thing to find the geometric property of the fabric is the cover factor. This value gives the value how much the warp and weft yarn covers the fabric. This determines the air permeability of the fabric. So in this case, we have to determine the cover fabric, but by just knowing the warp and weft count and ends per inch, pitch per inch, by using the formula, we have to find the cover factor of the fabric. For this, we have to use the counting glass. Like that, we have to think. The another thing, the fabric behavior during the tensile load, how the fabric yield for that tensile behavior. This is also going to learn in this module. So what is an woven fabric? Interlacement of warp and weft in a particular design manner. So for making a woven fabric cloth, loom should be used. Woven fabric structure is also playing an important role in case of geometric properties. The structure of the fabric depends on the end-use application of the fabric produced. What are the structural properties of a fabric to be determined? One is called cover factor, yarn linear density, structure of the fabric, mass per unit area, and crimp and fabric thickness. These are the surface properties of the fabric, geometric properties of the fabric. First, what is the face and fabric back of the cloth? So this is the uphill task for a technician to find the face and back of the fabric, which side to be exposed to sunlight, which side to touch the body of the fabric in the case of garment or any other material. So we have to identify the face and back of the cloth properly to identify the surface of properties of the fabric. Usually the face of the fabric will have more shiny than the back of the cloth. If you make the fabric towards the sunlight, see the fabric through the sunlight, there are reed marks which will show you the face of the fabric, which will more shiny than that of the back of the cloth. And although the face of the cloth will have more softer than that of the back of the cloth, so that we can identify this is the face and this is the back of the cloth. Then the another task will be to identify the warp direction, web direction of the fabric. The warp direction, if it is a cloth, will have selvage. The yarn running parallel to the selvage will be warp, and the case of running horizontal to the selvage will be weft. We can easily identify. And also warp yarn is also sized one and weft yarn is unsized one. And another case, it will have warp yarn will have lesser crimp and also weft yarn will have higher crimp. These are the method to find the warp and weft of direction of the cloth. So we are using some counting laws to find the ends per inch. How many ends per inch will be for warp yarn? Warp yarn is termed as ends, weft yarn is termed as peak. So finding the warp and weft per inch will help us to determine the cover factor of the material. And also we have to find the warp count, weft count of the material also. And thickness of the fabric using thickness gauge. Then surface properties of fabric will be crease recovery, warp and weft. Then stiffness of the fabric. By using the stiffness of the fabric, we will find the flexural rigidity and bending models of the fabric. Now, Geometric properties, how to determine the cover factor. Now by using the counting glass we are going to determine the ends per inch, and using the Beasley's banner we are going to find the warp count and weft count also. Using the counting glass also we are having picks per inch and weft count also in our hand. We have to use the formula. Cover factor of warp cover factor will be ends per inch divided by root of warp count in English system, which we can denote it as just a K1. Weft cover factor will be given picks per inch divided by root of weft count in English system, which will be denoted as K1. Now we will have two values called K1, which denotes the warp cover factor, and K2 will denote the weft cover factor. So cover factor of the cloth will be K1 plus K2 minus K1 K2 divided by 28. So this will give you the idea about how much openness in the fabric, how much warp and weft cover the fabric. If the cover factor is high, the air permeability of the fabric will be less. For example, if it is bandage cloth, gauze cloth will have a lesser cover factor. It will have more open surface. The warp and weft yarn will not cover that much of area in the 1 square meter of the fabric. So the cover factor will determines the openness of the fabric, how closely it will be woven. The maximum cover factor value of the cloth will be 28. Then we have to determine the stability of the fabric. Stability of the fabric is related to stiffness of the fabric. This test method covers the measurement of the stiffness properties of fabric. Bending length is measured and flexibility rigidity is calculated. Bending stiffness is a very important property which affects the appearance and comfort of a garment. It is defined as the bending moment required to produce a given curvature. Depends on the number of yarns being bent in the fabric and the bending rigidity of those yarns. For determining the bending stiffness, we are using stiffness tester. A sample of 6 inches length and 1 inch width of fabric is mounted on the horizontal platform such that it overhangs like a cantilever and bends downwards. The mean value of the bending length in warp and weft direction are found. Then from the bending length we are able to calculate the flexure rigidity denoted as G. It is the ratio of small change in bending moment per unit width of the material to the corresponding small change in curvature. G is given by m into c cube into 9.807 into 10 power 3 micro Newton meter. So where C is the bending length which is found during the stiffness tester. Similarly, the bending modulus also an important factor in the case of stiffness property. The bending modulus is independent of the dimensions of the strip tested, so that by analogy with solid material it is a measure of intrinsic stiffness. It is given by 12 into G into 10 cube divided by T cube Newton meter square, where T is the fabric thickness in mm, G is the flexure rigidity. Then how to find the fabric thickness of the material? A piece of fabric is placed on the preference plate on the instrument, ensuring that there is no crease in the fabric. While placing the fabric, it should be subjected to any stretching. The pressure foot is gradually brought down, and after allowing to rest on the fabric for 30 seconds, the gauge reading is taken. The fabric thickness is reading at 10 different places on the sample, and the mean of these readings is taken as an average measured thickness of the sample. Thickness of the cloth is expressed as in millimeter. Similarly, the grams per square meter of the fabric is going to be tested. The grams per square meter of the fabric is used to determine whether the fabric is heavy or lighter one. The grams per square meter we have to use GSM cutter. It is a round cutter kept on the surface of the fabric, and the weight of the round sample is measured with the help of the balance. On multiplying the weight by 100 we get the GSM of the fabric. Then how to find the thread density of the fabric, that is ends per inch, fixed per inch. We are using the counting glass. By using the counting glass, we have to manually count the material of warp and weft per inch using the counting glass. Then another important surface property of the fabric is it is the crease recovery of the fabric. Crease is caused by folding the fabric on itself and is identified by the sharp bend of the fold. If present where required, it has utility, otherwise it is undesirable. Crease is necessary for some place and crease is not required for in some place of the garment. In case of shoulder fold, the crease is required. In the case of chest area, the crease is not required in the garment. Crease resistance is defined as the resistance of the fabric to bending, deformation, and crease recovery is the ability of the fabric to recover from the imposed deformation. For testing the crease recovery tester is used for determining the resistance of the fabric. The crease recovery of the fabric is given by angle of crease recovery. For this, 10 fabric of each sample, which 2 inches and 1 inches is used for in both warp and weft direction, and the fabric is folded in the center and loaded by using 1 kg of weight, and the fabric is taken from the loaded cell. It is placed on the crease recovery tester. One end is clamped in the crease recovery, other end is allowed to recover. The crease recovery angle is measured by using the crease recovery tester in case of degree. Then another important measurement is called drape. The drape is the ability of the fabric to assume a graceful appearance. The drape meter is used to find the drape coefficient of the fabric. If the drape coefficient of the fabric is more, it implies that the bending of the fabric is more, so that it will be more comfort for the wearer. Drape is given by A3 minus A2 divided by A1 minus A2. Drape coefficient will be always less than or equal to 1. Then fabric strength test. Fabric strength can be of 3 types. One is called tensile strength, tear strength, and bursting strength. Fabric strength what are the terminology used for fabric strength will be breaking strength. It is a measure of the resistance of the fabric to a tensile load or stress in the warp or weft direction. Tearing strength, it is a measure of resistance to the tearing or either in warp or weft yarn. Bursting strength, it is a measure of composite strength of both the warp and weft yarn simultaneously and indicate the extent to which the fabric can withstand a bursting type of force with the pressure being applied perpendicular to the surface of the fabric. Breaking strength, mainly used for woven fabric because the tests are unidirectional and woven fabrics have unidirectional yarns. Factors that produce a strong fabric include fiber content, yarn size, yarn type, and weave type yarns per inch. Then breaking strength is expressed in pounds and the elongation is expressed as a percentage. Importance of breaking strength will be breaking strength is important in various end uses such as automotive safety belts, parachute harness, and pants. Breaking strength can also be used to test the effects of destructive forces upon a woven fabric, including sunlight, abrasion, and laundering. Then another thing is tearing strength. Tearing strength is the force required to continue to tear or rip already stated in a fabric. The test is used mainly in woven fabric because the test is unidirectional and the woven fabrics have unidirectional yarns. Tearing strength is expressed in terms of pounds or grams. Now we are going for tensile strength. The tensile strength of the fabric is the strength when a load is applied in either warp or weft direction of the fabric. The warp direction woven fabrics are often stronger than the weft simply because there are many more threads in the warp direction. Objectives of tensile testing: to check the fabric's conformity to specification, to note the effect of structural details of the chemical process, to obtain some indication of probable performance and use, to investigate the causes of failure and customer complaint, to study the interaction of fibers, yarn and fabric and properties. Testing method. The choice of testing method and machinery depend on required information. For heavy industrial fabric and for fine knitted fabric, some same method may not be used as the requirement is quite different. The sampling method. The fabric within 2 inches of the selvage should be used for testing because the region near the selvage often possesses slightly different properties to the body of the cloth. No two samples should contain same threads. When weft strips are selected, it is suggested that some of the strips should include fabric woven from more than one weft package to avoid carpent effect. Fabric preparation method for fabric tensile testing. One method is raveled strip tensile test. 25 mm wide specimen is prepared from 35 mm cut strip by removing approximately equal number of yarn from each side. When the load is applied, the yarn in the center of the strip absorbs the load and the yarn each side of the strip will support very little if any of the stress. Stress decreases with the increase in gauge length. Fabric preparation methods for fabric tensile stress testing. Second method is grab test. For this, the sample size will be 100 mm width and 150 mm length. Gauge length will be 75 mm. The specimen is extended at 300 plus or minus 10 mm per minute crosshead speed. Grab strength test is always greater than the strip test strength because the threads adjacent to the threads clamped between the jaws take up the load during the tensile strike. The strength increases with increase in the gauge length. Then fabric tensile test using the tensile load, constant rate of elongation test. Fabric tensile strength involves extending strip to the fabric to its breaking point by a suitable mechanical mean which can record the breaking load and extension. 5 fabric samples can extended in the direction parallel to the warp and 5 parallel to the weft. Now 2 samples to confirm the same longitudinal threads. Specimen size 60 mm into 300 mm frayed down to the width of 50 mm. Principal constant rate of extension. The extension rate will be 50 mm per minute. Gauge length will be 200 mm. Pre-tension is 1% of the probable breaking load. Any breaks within 5 mm of jaw should be rejected. The mean breaking force and mean extension of a percentage initial strengths are reported. Tearing strength of the fabric. Tearing strength is the force required to propagate a tear in the fabric under specified condition. Tearing strength is much less than the tensile strength, where a large number of threads must be broken together. More easily, yarn slip the greater the tearing strength. Plain weave which has maximum number of threads in section, possible yarn slippage will be restricted. Minimum tearing strength will occur. In case of twill satins have maximum number of tearing strength. Tearing strength is applied for finding the strength of shirting, interlining, technical fabrics, not suitable for knitted fabrics and non-woven fabrics. Method of measuring the tearing strength. The specimen size will be 200 mm into 75 mm is taken and cut off 85 mm is made along with the long center line of the fabric. This cut produces 85 into 37 mm tongue which are placed in the upper and lower jaw of the tensile strength tester. Element of tearing tester. It employs a pendulum to apply energy sufficient to tear through a fixed length of the fabric. The tear is of tongue type. Energy loss is equal to tearing force into distance. Loss in potential energy is equal to work done. The apparatus consists of a sector-shaped pendulum carrying a clamp which in alignment with a fixed clamp when a pendulum is raised starting position where it is maximum potential energy. The specimen is fastened between 2 clamps and the tear is started by a slit cut in the specimen between the clamps. The pendulum is then released. The specimen is turned as the moving jaw moves away from the fixed one. The pendulum possesses a potential energy because of starting height. Some of the energy lost in the tearing through the fabric so that as the pendulum swings through the lowest position, it is not able to swing to the same height as it started from. The difference between the starting height and the finishing height is proportional to the energy lost in the tearing of the fabric. The scale attached to the pendulum can be graduated to read the tearing force directly, or it may give a percentage of original potential energy. Then another important test for the fabric is bursting strength. The tensile strength of knitted fabrics cannot be accurately measured by using a strip or pulling stat and can be easily verified. These fabrics are therefore subject to a bursting strength which avoids this effect. The pressure required to burst a fabric is noted and termed as a bursting strength in the cloth. Generally applicable to wide variety of knitted non-woven fabrics and special purpose woven fabrics. Hydraulic bursting strength is used for making the bursting strength. Principle of bursting strength will be resistance offered by the specimen against a multi-directional pressure. Working of a bursting strength tested. The fabric tested to be clamped over a rubber diaphragm by means of an annular clamping ring, and increasing fluid pressure is applied to the underside of the diaphragm until the specimen bursts. The operating fluid will be a liquid. In the test of the fabric sample clamped over a rubber diaphragm, the pressure fluid increased at such a rate that the specimen burst within 20 plus or minus 3 seconds. The extension of the diagram is recorded and another test is carried out without a specimen present. The pressure to do this is noted and then deducted from the earlier reading. The bursting strength of the fabric is expected in the case of kilonewton per meter square. So after learning this module of geometric properties and tensile properties of the fabric, one is able to find the GSM of the fabric, warp count, weft count, and the cover factor, stiffness of the fabric, structural rigidity of the fabric, bending modulus of the fabric, drape of the fabric, and also tensile strength, grab test, and also tearing strength and bursting strength of fabric, which will help the student to understand the concept of surface and geometric properties of a fabric, so that they can design the fabric according to the end uses.